Hello everyone. We are going to talk about linear modeling today, which probably sounds a little more complicated than it actually is. Linear modeling just means we're going to use an equation to model what's actually happening. So let's talk about a scenario that might actually be something of interest to you. For example, let's say you found in your wallet that you had $5. I'm going to put a point right here at the 5. And let's say your mom decided she was going to give you $1 every 2 weeks for doing your chores. So the bottom of this would be weeks, the x-axis, and the right side here, left side here, would be dollars. And if you earned $1, you would go from 5 to 6 over 2 weeks. And if we kept going, you would see points that look like that we could actually write the equation of this. Now, notice that our starting point is 5. We're going to interpret that as b equals 5. And remember that we went up $1 every 2 weeks. That, in essence, is our slope, which would be 1 over 2. So to write the equation of this linear model would look something like y equals 1/2 x plus 5, because remember we're always using this equation y equals mx plus b, where m is the slope and b is the y-intercept or the starting point. Another scenario could be something like you found $10, and again I'm using the same axes here, weeks and dollars. And let's say you found $10 and decided that you were going to spend $2 every week. So you would go from 10 down to 8 in 1 week, down to 6 in another, and you would have something that looks like this. We could also write this equation. And again, if you notice here, you have a starting point or a b of 10, and your slope is a little different here. We're going down 2 over 1. We would call that negative 2 over 1. And we would write this equation as y equals negative 2x plus 10. A couple more thoughts to think about is if you look at the bottom left graph, you notice I have a point here at 0. And let's say your mom decided to give you $3 every 5 weeks. You would be going up to 3 and over 5. And notice that the difference here is your starting point is actually at 0, and your slope, and you could pick any set of points that you wanted because they're all the same, would be 3 over 5, meaning $3 for every 5 weeks. And when you write that equation, it would look something like y equals 3/5 x. You could write plus 0 if you like, and if you didn't, plus 0 really doesn't have a value. You could just keep it as y equals 3/5 x. And I'm going to just focus on what's going on in these graphs here. Notice that we have two relationships here that are increasing. This one here, the money is going up, as is this one, whereas this one on the right side here, that's a decreasing relationship as the money is going down. There is one other possibility, and that is something like, let's say you had $6 in your wallet and you don't do your chores ever. You would have a relationship that looks something like that, and that's what's known as a constant relationship. The money isn't going up or down, but still notice that you would have a starting point of 6 or a y-intercept of 6, and your slope, you're not really going up at all. You're staying flat. Your slope would be 0. So your equation, I guess you could write it as 0x plus 6. Most of the time we just write that as y equals 6. Okay, let's do a couple more examples. Okay, so let's talk about Paul. Paul emptied his piggy bank and found $2. He now receives $5 every 4 weeks for keeping up his neighbor's lawn. So I'm going to start by making an XY table, which means he started with $2, so that's really at time 0, week 0. And then every 4 weeks, he earns $5 more. So if I added 5 to 2, I would get 7. And 4 weeks later, I'm going to add 5 to 7 and get 12. 4 weeks after that, adding 5 to 12, I'm going to get 17. And 4 weeks later, I'm going to add 5 to 17 and get $23. And what I want to point out here is if you look at this table, the Y values, which are going to represent our dollars, are going up by 5 every single row, and our weeks, which are the X's, are going up by 4. And the reason for that is that's because that's what this scenario involves. He's making $5 for every 4 weeks. Taking a look at number 2, first off, notice there's a typo. It should say how much money will Paul have after 4 weeks and 8 weeks. And if you look at your table, you can see that right there. At 4 weeks, he will have $7. At 8 weeks, he will have $12. Now we're going to graph the data, graph what's on the table. You may notice that I've graphed the points 0, 2, 4, 7, 8, 12, 12, 17, 16, 23, and I am going to connect it with a line, and that is a graph of my data, and I should make sure that I label my axes with dollars and weeks. It's not always dollars and weeks, but it is for this problem. Now the next question asks us to write a linear model to represent this situation. Well, I'm going to go back to what we did at the beginning. Notice that we have a starting point or a y-intercept of 2, and picking any of the 2 points that I graphed, or thinking back to how he was earning $5 for every 4 weeks. I'm going up 5 and over 4. That is my slope. So my linear model, or my linear equation, would be y equals 5/4 x plus 2. Now using the graph or the table, you can see a lot of information, you can get a lot of numbers, but our graph only goes up to 16, and it's hard to read what's in the middle at times. So for that reason, you do need to write the equation to answer the questions that follow. Notice in number 5, it says, using your equation, predict the amount of money that Paul will have in 10 weeks. Well, again, I'm going to remind you that X is the weeks, time is always X, and Y is the dollars, or the money. So I'm taking a look at number A. Notice that it says, letter A, we're predicting the amount of money in 10 weeks. Well, we're going to use our equation, so I'm going to start by writing my equation, y equals 5/4 x plus 2, and it gives me 10. So that tells me, since x is weeks, I'm going to plug 10 in for x, and then I'm just going to evaluate this. Use your calculator or do it in your head. 5/4 times 10 is 12.5 plus 2. So after 10 weeks, Paul will have $14.5 or $14.50. Taking a look at B, really the exact same question with a different x value. We're going to use our equation like we did before, but in this case, notice that it asks how much money will Paul have in 16 weeks. So I'm going to plug 16 in for x, and then again I'm going to evaluate. 5/4 times 16 will give me 20, plus the $2 that we started with leaves us with $22. Paul will have $22 in 16 weeks. C is just a little bit different. If you notice, we're given the money. So in this case, we are still going to use our same equation, but it doesn't give us the number of weeks. It actually gives us how much money he has, and the question is, how many weeks will it take him to earn the $327? So we are going to plug in $327 for y and solve for x. This one is a little bit more work, but nothing that we can't handle. We're going to subtract 2 from each side, and we are going to end up with 325 equals 5/4 x, and we're going to divide both sides by 5/4, and we are going to end up with x equals 260 weeks. That's a lot of time to earn $327. And lastly, the last question here says, if Paul wants to buy a new game for $52, can he buy it within a year? Well, keep in mind that a year is 52 weeks. So really what this question is asking, will he have $52 in 52 weeks? Well, best way to do that is to plug in 52 for your x and see what you end up with. When you multiply 5/4 by 52, you end up with $65 plus the 2, and a total of $67 in 52 weeks. So if he wants to buy a game that is $52, can he do it? Yes. Homework is just like this, a little bit shorter on Schoology. If you have any questions, email me. Good luck.